2 decades ago, ultra-long-haul flying felt like the absolute frontier of commercial aviation. At the start of the century, flying between far-flung financial capitals like New York and Hong Kong without stopping was considered almost experimental, technically possible, but economically risky. In March 2001, a Continental Airlines Boeing 777 departed Newark and flew north over Canada, across the Arctic, down past Russia and East Asia, before landing in Hong Kong after roughly 16 hours in the air. At the time, this was a remarkable achievement, not because airplanes had never flown that far before, but because airlines had never been confident they could make money doing it. Long-distance routes traditionally relied on stopping points: Tokyo, Anchorage, Bangkok, or Singapore, because aircraft burned less fuel overall when they didn't have to carry enormous quantities of fuel for a single stretch. But aviation would soon change. Over the following 20 years, technological progress, shifting economics, and changing passenger expectations combined to transform ultra-long-haul flights from rare prestige routes into a growing core strategy for global airlines. Today, flights approaching 19 or even 20 hours operate daily across the planet. And what once sounded impossible, flying nearly halfway around Earth in a single sitting, has become routine for thousands of passengers every day. The biggest catalyst for this transformation wasn't speed, but efficiency. Aircraft never became dramatically faster after the jet age matured. Modern airliners cruise at roughly the same speeds as their predecessors from the 1990s. What changed instead was fuel consumption per seat. New composite-heavy aircraft like the Airbus A350 and Boeing 787 Dreamliner drastically reduced fuel burn. Not just a little, but enough to alter route planning entirely. Earlier long-range aircraft such as the Airbus A340 technically had the range for extreme routes, and airlines even attempted them. Singapore once flew non-stop from Singapore to Newark in the mid-2000s. But rising oil prices quickly made those flights unsustainable. The aircraft simply burned too much fuel for too few passengers. The newer generation, however, reversed the equation. Carbon fiber fuselages lowered weight, higher bypass engines increased efficiency, and improved aerodynamics reduced drag. Suddenly, airlines could operate very long routes without losing money, provided they filled the right seats. And that distinction became crucial. Ultra-long-haul flying does not primarily exist for economy travelers. It exists for time-sensitive passengers willing to pay for convenience. Airlines discovered that passengers value time differently. Leisure travelers will accept a cheaper ticket with a connection. But business travelers, executives, consultants, engineers, financial professionals, place a much higher value on arriving quickly and predictably. A non-stop flight removes missed connections, delays in unfamiliar airports, overnight layovers, and schedule uncertainty. That reliability allows companies to justify higher fares, and those fares make ultra-long routes viable. This is why many of the world's longest flights are configured unusually. Some aircraft flying nearly 19 hours carry fewer passengers than shorter flights on the same plane type. Seats are larger, cargo lighter, and premium cabins expanded. Singapore Airlines famously reintroduced its Singapore Tunawork service using a special configuration with no traditional economy class, focusing instead on premium economy and business seating to maximize revenue per passenger while keeping weight low. The goal was not to move the most people, but to move the most valuable travelers. There is also a surprising physics problem behind these routes. Airplanes burn fuel to carry fuel. At medium distances, non-stop flying is efficient because avoiding an extra takeoff saves energy. But beyond a certain point, the aircraft becomes so heavy with fuel that efficiency decreases again. Historically, this meant extremely long flights actually used more fuel overall than two shorter segments combined. For decades, this favored hub airports located between continents: Dubai, Singapore, Hong Kong, Doha, where airlines built enormous transfer networks connecting Europe, Asia, and Oceania. Instead of flying London to Sydney directly, passengers would connect in the Middle East or Southeast Asia. Airlines based in these geographic crossroads became extraordinarily successful by specializing in one-stop global connectivity. However, once aircraft efficiency improved enough, the balance shifted. Even if a non-stop flight burned slightly more fuel, passengers preferred it, and the higher fares compensated for the extra cost. That's why the late 2010s and early 2020s saw a sudden explosion in ultra-long routes. Airlines began linking city pairs once considered permanently separated by distance. The United States to Singapore, Australia to Europe, Southeast Asia to the American East Coast, and the Middle East deep into North America. The longest regularly scheduled flight now stretches close to 19 hours between Singapore and New York, while several others exceed 17 hours daily. What changed wasn't geography. The Earth stayed the same size, but economics and expectations. Travelers grew accustomed to direct connectivity, and airlines realized the prestige of the world's longest flights also served as powerful marketing. At the same time, fuel prices played an invisible but decisive role. Aviation fuel costs fluctuate dramatically, and ultra-long-haul routes exist on a narrow margin. When oil prices fall, airlines rapidly expand long routes. When they reshape, these flights are often the first reconsidered. During the pandemic recovery period, airlines reevaluated networks and noticed something important. Passengers increasingly preferred avoiding connections entirely. Health concerns accelerated a trend already underway. Direct flights became more attractive than ever. Airlines responded by restoring and launching more non-stop routes than before, especially between major global business centers. The strategy shifted from funneling everyone through giant hubs to offering direct city-pair connectivity wherever demand justified it. This development also threatens traditional connecting hubs. For decades, Gulf carriers and certain Asian airlines thrived because geography forced travelers to stop midway. But as aircraft range increases, some of that connecting traffic bypasses them entirely. A passenger flying Australia to Europe can now skip the transfer airport altogether on certain routes. While not every city pair can sustain such flights yet, the gradual expansion of ultra-long-haul capability redistributes global aviation power. Airlines closer to passengers rather than halfway between them gain an advantage when technology removes distance barriers. Ultimately, ultra-long-haul flying represents the final phase of shrinking the planet. The jet age first made continents reachable within a day. Then modern efficiency made them reachable within a single continuous journey. The aircraft aren't flying faster than before. They're simply eliminating interruptions. What once required multiple stops, overnight layovers, and complicated itineraries now happens in one boarding and one landing. As newer aircraft variants promise even greater range, airlines are approaching a point where nearly any two major cities on Earth can be connected directly if economics allow it. At that moment, distance stops being a technological limitation and becomes purely a market decision determined not by whether planes can fly that far, but whether enough people are willing to pay for the convenience of never stopping. As ultra-long-haul flying matured into a viable strategy rather than a publicity stunt, airlines began to realize its most profound impact was not technical, but geographic. For nearly half a century, global air travel had been organized around hubs positioned between continents. Airports in the Middle East and Southeast Asia thrived because they sat naturally between Europe and Australia, or between North America and South Asia. And airlines based their built enormous transfer operations designed to collect passengers from dozens of cities and redistribute them onward. The model depended on distance. Travelers accepted stopping halfway because they had no alternative. But once aircraft range improved enough, that logic began to erode. When a traveler can board a plane in one city and step off in another, across the world without immigration lines, security rechecks, or the anxiety of missing a connection, the appeal becomes overwhelming. Even if the ticket costs slightly more. Airlines discovered that time reliability, not just total travel time, is extremely valuable. A non-stop journey removes uncertainty, and uncertainty is what businesses pay heavily to avoid. This is why routes between wealthy, globally integrated cities became the testing ground for the longest flights. Financial capitals, technology centers, and political hubs generate predictable premium demand. The passenger profile on these flights differs from the typical vacation route. Luggage loads are lighter, corporate travel budgets are higher, and schedule flexibility is minimal. Airlines tailor cabins accordingly. Instead of maximizing seat count, they maximize revenue per square meter of cabin space. Larger seats, lie-flat beds, improved air pressure systems, and advanced humidity control all matter more when passengers remain on board for nearly 20 hours. Aircraft interiors have evolved into controlled environments designed to reduce fatigue. Dynamic LED lighting simulates day-night cycles, cabin altitude is kept lower thanks to composite fuselages, and meal services are timed to destination time zones to reduce jet lag. Ultra-long-haul flying therefore changed not only networks, but aircraft design priorities. Comfort became a financial necessity rather than a luxury feature. Another unexpected effect is cargo logistics. Passenger airlines carry significant cargo in their belly holds, but ultra-long-haul flights limit payload because weight directly affects range. That means airlines must carefully choose between passengers, baggage, and freight. On some routes, cargo revenue is sacrificed entirely to preserve range margins against strong headwinds, especially during winter polar crossings. Freight carriers, by contrast, rarely adopt these extreme distances because their economics differ. Cargo shippers tolerate a short refueling stop if it reduces fuel burn. As a result, the passenger aviation world is now slightly diverging from cargo aviation. Passenger airlines chase nonstop convenience, while freight operations still optimize for efficiency through staging points. The sky therefore contains two overlapping but economically distinct route networks. These developments have also reshaped competition between airlines. For decades, a traveler flying between secondary cities depended on connecting through massive hubs run by a small number of powerful carriers. Now, long-range narrow-body and efficient wide-body aircraft allow airlines to bypass those hubs and link secondary cities directly across oceans. This fragmentation weakens the dominance of mega-hubs and distributes international traffic more evenly. Airports once considered too remote for intercontinental service now host non-stop flights to distant continents, stimulating local economies and business travel. Instead of concentrating global connectivity into a handful of transfer airports, aviation is gradually yet the expansion is constrained not by technology anymore, but by economics and human endurance. Beyond roughly 20 hours, passenger tolerance becomes a limiting factor regardless of comfort improvements. Airlines must balance prestige against practicality. A slightly shorter one-stop journey may still attract customers if fares differ significantly. Fuel price volatility adds another layer of uncertainty. Ultra-long-haul flights operate profitably only within certain fuel cost ranges, and airlines continuously model whether each route remains viable months in advance. Some routes appear and disappear over time not because aircraft cannot fly them, but because market conditions temporarily shift. In this way, the map of the world's longest flights constantly evolves, reflecting global economic cycles as much as engineering capability. Looking ahead, the next phase of aviation may not be about making flights dramatically longer, but making them flexible. Aircraft manufacturers now design variants capable of operating both high-density medium routes and low-density extreme routes efficiently. Airlines can adjust cabin layouts depending on demand, more premium seating for financial corridors, more economy seating for leisure markets, turning one aircraft type into multiple economic tools. The concept of range is no longer a hard boundary, but a spectrum airlines can exploit strategically. Meanwhile, sustainable aviation fuels and improved engine technology aim to reduce emissions, a crucial factor since ultra-long flights concentrate fuel burn into single journeys. Environmental considerations may ultimately shape which routes survive. As governments and consumers scrutinize carbon intensity per passenger, there is also a psychological dimension to the shrinking planet. Direct flights subtly change how people perceive distance. When journeys require multiple stops, destinations feel remote. When they require a single boarding pass, they feel connected. Business relationships expand, tourism patterns shift, and migration flows adapt to perceived accessibility. Aviation has always compressed geography, but non-stop ultra-long-haul flights compress it further by removing friction rather than minutes. The world does not physically become smaller. Instead, interruptions disappear. The modern traveler increasingly expects to move between continents as easily as between regions once connected only domestically. Ultimately, ultra-long-haul aviation represents the final maturity of the jet age. Early commercial aviation overcame oceans, then reduced travel times, and now eliminates intermediate steps altogether. The technological race is nearly finished. Aircraft can already connect almost any two major cities on Earth. From here forward, the deciding factors will be demand, fuel, economics, and environmental policy. Some city pairs will gain direct links as global business ties deepen, while others will remain better served by connections. But the concept itself has proven permanent. The era when distance forced a stop is ending. Airlines are no longer limited by how far airplanes can fly. They are limited only by whether enough travelers value the ability to board once, wait, and arrive on the other side of the planet without ever stepping into another terminal.